We are asked to find the area of the bounded region created by these three curves. The first thing I'm going to do is graph those three and try to find the bounded region where the perimeter of the region touches all three of these curves. Let's go ahead and do that. Notice that if you graph these three curves, we actually have two bounded regions that touch all three curves. We have the one here in the first quadrant and the one here in the second quadrant. Let's go ahead and assume that we just want to find the area in the first quadrant. If this were a real test on Moodle, or if this were on the test, it would specify that if they do have two regions that are bounded, it will specify which one that we want to find the area of. In this case, we'll use the first quadrant. Let's go ahead and do that. Notice that the top of this region, let me go ahead and shade that region. There we go. Notice that the top of this region is the line y equals 4, and the bottom of that region is the curve y equals x squared. So from y equals 4 on top to y equals x squared on bottom. Now I know which piece is my top, which piece is my bottom. At this point, we want to integrate from the left-handmost value. Notice that there's actually a lot of left-handmost values, but they all have x value of 0. So we want to integrate from an x value of 0 all the way to an x value of 2. The rightmost point is 2, 4. The leftmost point would be 0, 0, although it is tied along this y-axis. So we're going to integrate from 0 to 2, and we know y equals 4 is on top. Again, I would specify, if this were a real problem, that we're looking for the area of the region in the first quadrant bounded by those curves. Now the area we just said is going to, well, the integration is going to go from 0 to 2. We saw that y equals 4 is on top and y equals x squared is on bottom in that section. I'm going to rewrite that, or at least make it look a little bit nicer. I threw in a lot of parentheses there. Let's take out those parentheses. I'm going to rewrite it in descending order as well. So negative x squared plus 4. Now I can take the antiderivative. Negative 1/3 x to the third plus 4x plus any constant that I want. I'm going to choose a constant of 0 to make my life easier. Plug in 2, plug in 0. Let's go ahead and plug in 2, 1/3 times 2 to the third power plus 4 times 2. When you plug in 0 into this polynomial, you will get out a 0. Oh, you know what I forgot? I forgot the negative sign out in front of the 1/3. My apologies. All right, so 8 is what you get when you take 2 to the third, also what you get when you take 4 times 2. What I ended up with as a final answer is 5 1/3 as an exact answer. If you wanted to do an improper fraction, 16/3. If you wanted to do an approximate value, 5.33, rounded to 2 decimal places. So there you go. That's how to find the area of a bounded region created by curves. It's the same area formula as we've done before. We just have to figure out the bounds and figure out which one of our functions is on top.